Alright, so here we go, class of 2. Alright, today I want to talk about something called.
Wait, go a bit lower.
Lower?
Yeah.
Here?
Yeah, that's great.
Exact ratios. Now, exact ratios work with this: 45 degrees, 60 degrees, and 30 degrees. They're the 3 angles that we use for exact ratios. And to do exact ratios, we actually have to construct 2 triangles. So I can hear the guy working outside. First triangle looks like this. It's an isosceles triangle with a unit length side. Now, unit length means 1. If we find the hypotenuse by Pythagoras, what will that be? If you think about it, c squared is equal to a squared plus b squared.
2.
Yeah, it's going to be square root of square root of 2. Yeah? Now, see that surd? The square root of 2? If we leave it as a surd, it's an exact answer. Which now means that from this triangle, I find this. Oh, hang on, let me ask you another question. If these are the same, what's this angle and this angle? Because it's an isosceles triangle. What do we know about an isosceles triangle? 2 sides are the same. But what do we know about the base angles?
They need to add up to the 2 base angles are the same.
These are the same.
Yeah.
Right. But this is 90.
Oh right, so
these
they're 45 each.
They've got to be 45. So instantly that tells me that's 45 degrees. So if I can memorize this triangle, I can say this. Sine 45 degrees is equal to, what would that be equal to? Remember, sine is opposite over hypotenuse.
1
on root 2. Done. Now, if you try to do sine 45 on your calculator, what do you get?
Sine 45.
Yeah. So this is exact.
Wait.
But on your calculator, what do you get?
Sine 45 is 0.71.
See how it's not exact? It's an approximation. If you want an exact answer, because these angles show up all the time, if you want an exact answer, you've got to use the square root. So we don't use this. This is an approximation. Instead, we use that or this. Cos 45 adjacent over hypotenuse. Tan 45 is opposite over adjacent. So when it comes to 45, we look at this triangle. When it comes to 60 and 30, we start with this triangle here. Do this in another colour. This one here. Right, and I'm going to tell you that's 2, and that's 2. What kind of triangle is that?
Equilateral.
Equilateral. Equilateral triangle, all sides are the same, all angles are the same. What does that make all the angles?
4.
They've got to add up to 180. Okay, that's 60, 60, 60. Yeah?
Yeah.
But that's not the actual triangle I want. Instead, what I'm going to do, because it's completely symmetrical, right? I'm going to cut it in half. What I'm going to do is this. Because what that does is it gives me a 90-degree triangle, which is great. I know this one is 2. Because this one's been cut in half, this side here has got to be 1. And now, I can find, by Pythagoras, I can find this third side here.
Yeah.
But it's a shorter side, so it's going to be a minus. So I'm going to say b squared is equal to c squared minus a squared. B is going to be equal to 2 squared minus 1 squared, square root of 3. So this turns out to be square root of 3. But not only that, see how this was 60? Okay, fair enough, that's 60. You see how I cut this in half and this became 1 and that became 1? I also cut this angle in half.
So 30.
So this now is 30. And this triangle now becomes really important because I can look at this triangle and if I'm looking at 60, I can say, look, what is sine of 60 degrees? And the sine of 60 degrees is opposite over hypotenuse. And cos of 60 degrees from this very triangle would be adjacent over hypotenuse. And tan of 60 degrees would be TOA, opposite over adjacent, which would be root 3 on 1. Do I have to write the on 1?
No.
But what about if instead of using this angle, I use this angle? Sine of 30 would be opposite over hypotenuse. See, because now I'm using this angle. Opposite to the 30 is 1 on 2. Cos of 30, well, that would be adjacent over hypotenuse. And tan of 30 would be opposite over adjacent. So I have to I can do 2 things. I can memorize this and this and this, because you have to know them. Or I could memorize this and this, just this half section there. It's up to you how you remember it. Me personally, I always go with the diagrams. Because the minute I have the diagram for here, I've got all of that. Yeah, I find that the diagrams are not too hard to remember after a while. Okay? Questions? Simple, right? Too easy. That's it.
Okay.
All done.